We have tiny unboxing day today. I received a few little thingies, robotics components you can call them, but they are DC to DC, step down and boost circuits. Not exactly what I wanted. They shipped some more expensive stuff that are not really appropriate. Not what I asked for, but I take it because they are more expensive. So yeah, this is what I'm talking about. I can show it under the microscope. It's an OKY3501-1, and I asked for the 3504, which can step down voltage to down to 1 volt. This can only do down to 5 volts if I don't figure out how to modify it. It has let me just open the package. Yeah, I think going forward we're gonna look at tiny electronics under the microscope only. Makes no sense to just record it with the camera. So as you can see, it has a standard USB and nice little step down circuit. Is it clear? So it has some diodes, I think, on top. In the middle it's a coil resistor R10 or R10, whatever. And down here some capacitors, a resistor, another capacitor probably, a chip that's called IAELN, sure, another resistor, capacitor, an LED that shows you when it's on, and that's not really good for my applications. Well, that's why I didn't order this one. I ordered something else and got this. I assume whenever it has power, that will light up, and that's not really good. I would have liked it only to light up when I'm using it, when something is plugged in and charging. So yeah, there are those resistors on the bottom and the capacitor. So hopefully I can modify this to I need 4.2 volts because I want to power old cell phones that have a dead battery. I want to power them from a USB and or not necessarily USB, maybe a 5 volt 12 volt power supply, but I'd wire them in instead of the battery so they can run from the USB and act as webcams, Wi-Fi cameras and whatever. So yeah, hopefully I can modify this. If I can't, then it's basically a car charger that supports 3 amps output and 5 volts. So that's also very useful. All my chargers can do 2 amps max, 2.1, and yeah, this is faster, and maybe I saw there are still some holes here. Maybe I can solder another USB port into these 3 holes. As you can see, they are basically parallel to the identical to the other port. So maybe I can solder something into there and have 2 USB ports, because realistically 3 amps is too much for the average smartphone. I have old smartphones that I still use from time to time that take 1 amp, 1 or maximum 2 in the best case, because they also have really small batteries. So yeah, so you just wire up the 6 to 24 volts to these terminals here, negative and positive, and it will output 5 volts. Hopefully I can modify one of these resistors and make it output 4.2. That would be ideal. But yeah, I can use it as is for $1.2. I think that's how much I paid for it, but it should have been $2. Either way, it's kind of a fair price, considering that all the components seem really reliable, not the janky type that standard car chargers use. This coil is the best, which is housed or whatever you call it. It's not, you don't see the coils. It's all encapsulated in ceramics or plastic or whatever. So yeah, this is one of the things. That's $2 on the website. And here's another one. OKY3501-6 SU68. I don't know what that means, but this is let me just open it. It's a DC to DC boost circuit that has a micro USB input, or these terminals. You can also use the 2 terminals here for positive and negative. And yeah, this uses one of these coils, which means this is probably limited to 2 amps. 2 amp input on the 5 volt side, and yeah, you calculate how much it can output with roughly a 10% loss. Usually that's how much they lose in form of heat. So this is a DC to DC boost circuit, buck regulator, whatever you call it, step up. Yeah, basically this is the chip, I think, B628. Some capacitors, resistors, diode here, I think, this one, another capacitor here. Yeah, it must be a capacitor because it's C, and this is a diode because it's D, and the resistor is R. Okay, it makes sense. So, but it has a potentiometer here from which you can exactly tune in the voltage which you want to boost up to. So this can come in handy for 12 volt LED strips or routers or whatever that you want to run off a power bank or a USB charger or whatever. You can power it with this. You can make a really nice flashlight, working light, whatever, with an LED strip and this thing. The average power bank gives you 2 amps on 5 volts. That's 10 watts. And that should power 1 or 2 meters of LED strips. So you can make a nice light bar or shape it in a rectangle or whatever to have a nice little light, portable light. And on the average power bank, let's say on the smallest ones, like 5,000 or 6,000 milliamp hour, it should last for about an hour. Am I saying that right? About an hour. Yeah, somebody will correct me. It's really early or very late, depending on how you see it. So yeah, this one has really long legs here. That's why it was not flat on the table. So yeah, This was $1.2 real price. They didn't send it to me by mistake. This is really 1.2. And one more thing that is kind of interesting that I want to fool around with. It's a tiny little boost circuit. Oh, let me show the model number here. OKYSN S? Yeah, I guess that's an S. 3173 SU1. So this is a tiny DC to DC boost circuit, and what's nice about it is that it has basically jumpers. You can call them jumpers, I think, which set the voltage. So here's the circuit. I see it's the same chip as on the other one. Wait. B628. B628. Okay. I realized something. Okay. But the coil is slightly different. I believe this officially does 2 amps. Or 3? I'll have to look that up. So the coil is the encapsulated one, not the naked one, so I like these more. Yeah, the input is clearly marked. And yeah, mostly the same components, and it also has an LED here on the end, LED 1. And what's interesting about this is that it has two jumpers here, A and B, and they are both closed now, and they set the voltage. So on the back, it's yeah. So if they are both open, it doesn't do anything. It's just 5 volts. If B is closed, then 8 volts. A closed, 9 volts. And if both are closed, then it's 12 volts. And now it's configured to 12, which I need for an LED strip. And I just connect it right up. And it's really small, so if I have a USB plug, it fits inside. If I can wrap it with something, it fits in the part here, in the plastic part here. So that's how I imagine it, that I will put it inside somehow and encapsulate it in hot glue or something. And yeah, this also I used already. I used it with my 12 volt LED strip. That's kind of powerful, 14 watts per meter, and I used quarter of a meter, and it barely got hot. Slightly hot to the touch, but I could keep my finger on it, so it's like 40 something degrees Celsius when it's powering the LED strip. And yeah, I used it a lot for several days total, like 100 hours, maybe 200, and it works fine. Yeah, so these are what I got. I still have to pick up some other packages which arrived really late because reasons. I don't know why the couriers have problems nowadays, and Black Friday is coming up, so whatever you order now, especially here in Romania, Europe, maybe in 2 weeks. You can expect them in 2-3 weeks, whatever you order now. So yeah, these are the electronics I got, and what's coming is a very nice LED strip that has 320 LEDs per meter. So that's almost a continuous bar of light, and that will be very interesting. And what else? I don't remember. I will see when I go pick it up. And yeah, so that's how they look under the microscope. And yeah, hope to use them. One more thing you can notice under the microscope, this is almost a brand new desk, and this is how it looks. It has some dirt, but as you can see, the finish is not perfect. All these black dots are here that are impurities or bubbles in the paint when they were putting it on. It's what do they call it? It's really hard coating. Um, the name escapes me. But anyway, it's the cheapest one. It's a Chronospan brand, and yeah, this is how it looked brand new like a year ago, and this is how it looks now. I took out from the closet a small piece that wasn't touched, wasn't used, brand new, and looked at it, and it looks exactly the same with these tiny little imperfections all over it. So yeah, what you gonna do? At least I know it wasn't my fault. I didn't rub these imperfections in. So yeah. Oh yeah, I'm being stupid here. This must be just sawdust. As they coat the raw PAL particle board, whatever you call it. The particle board that's compressed together so the two sides are really, really flat and smooth. But some tiny little dust particles escape and get into the paint apparently. So yeah, that's the story behind that. See you in the next video.